Okay, everyone. So we have talked about the intro to the immune system, and now we're going to talk about the communication between the innate immune system to the adaptive immune system. So let's see. This is where we're at. So the phagocytes, the ones that are also antigen presenting cells, which are these guys here, once they have engulfed the antigen, like I said, they chop these antigens up and then they present it, they put it back on their surface, and they recruit the adaptive immune system. So here is like pathogen is going to damage the epithelium, so like broke the skin, and they were able to enter the body, okay, causing, this is the epithelial cell is depicting here inflammation, so it's activated because when the epithelial and endothelial cells get activated, once they are the ones that recruit, that start inflammation, and they recruit the immune system to come upon them. Chemokines and cytokines are going to, these are mediators, messengers that are going to be communicating with each other, and then are going to, they are activated by these epithelial cells, and they are going to recruit the innate immune system. Mainly the first ones to arrive at the place are the neutrophils. That is going to lead to vasodilation, or to inflammation. So the epithelial cells get activated, okay, they start to form certain chemokines and cytokines, they're called messengers or mediators. They are going to lead to vasodilation, okay, so this is a blood vessel. This here is a blood vessel, so blood, and then the neutrophils are inside these blood vessels, and part of inflammation that we're going to see here in a second is vasodilation. The vasodilation happens, so that's the blood vessels increase in size and diameter, and that happens to bring in even more blood to the area, to bring in more of the defense to the attacked area. There's also going to be, so this is what we see here. As you guys can see, the vasodilation, so now the blood vessel is increased in size, and then there's going to be little separation in between the cells that are going to cause the leakage of fluids that go from inside the blood vessels, and now they're going to leak to the tissue, okay? So this blood vessels are little, there's going to be little gaps in between the cells, and are going to allow the leakage of this fluid, and is also going to allow for the neutrophils to, what we call, transmigrate. So the neutrophils are going to come, so you see here the leaking of fluids. The neutrophils are going to come, and they get close, they are rolling along, and they get close to the endothelial wall, and they then leak to the tissue. So this outside here is the tissue, and this is all part of inflammation, okay? This inflammation, there's 5 cardinal signs of inflammation, and it is heat, swelling, redness, pain, and loss of function, okay? Heat, swelling, redness, pain, and loss of function, and everybody needs to be able to memorize what the 5 cardinal signs of inflammation are. Heat, why do we have heat in the area? So all the cytokines and chemokines are going to lead to vasodilation. More blood to the area is going to lead to heat. Blood is hot. Swelling, we're going to have swelling, which is also called edema, in the area, because these leaky vessels are going to lead to swelling, because this fluid is going to go outside of the blood vessels into the tissue. So leaky vessels lead to the swelling. The redness is going to, and this is not just the skin, okay, guys? This also happens in any organ that is inflamed that we can't see. The redness is because obviously blood is red, so there's going to be more blood in the area, more the redness, pain. These mediators, these when we are going to talk about the inflammation in the inflammatory cascade, we're going to see how the mediators work, and some of them are going to cause pain, such as prostaglandins, okay? and loss of function. Loss of function is because that area, as it is trying to heal, as it is inflamed, that particular area doesn't work as a normal of that area is. So for example, if you have an inflamed liver, even if it's that one area of the liver, that inflammation, that area that is inflamed is not going to work as regular normal hepatocytes would be working. Okay, so don't confuse loss of function with lameness or cannot use the leg, because this is not it. We're not just talking about exterior, we're also talking about organs as well. So loss of function means that that area, even if it's a skin, the skin is inflamed and there's a cut and there's inflammation, that skin is not working as it should. Okay, so it may be a little bit more stretchy, it may be a little bit it's inflamed, it's hurting, it's not protective as it used to be. I mean less stretch, not more stretch. Okay, the inflammation that is caused in that particular area is going to allow the entry of these immune cells to the site of infection. So here we have the epithelial cells, they get activated, leaky fluids, neutrophils are going to come to the site of inflammation. Inflammation is all this that's happening. We're going to have this phagocyte. So we're going to have the bacteria, the chest laceration as an example. The bacteria is going to break the skin barrier, activate the epithelial cells. Cytokines and chemokines are going to be produced and released. Okay, the epithelial cells themselves are going to produce them. They start with arachidonic acid. Okay, and in the presence of an enzyme formed into thromboxane A2, and then from that point on forming into prostaglandins, leukotrienes, etc. These cytokines and chemokines are going to lead to inflammation. Inflammation is going to lead to vasodilation. Okay, and also the cellular events, the phagocytes are going to start arriving in the area. We're going to have inflammation, leaky vessels, more things in that area to try to bring in even more phagocytes to try to kill the bacteria. We have then some lymphoid organs, and these lymphoid organs are part of the adaptive immune system. And we have the central lymphoid organs such as the thymus and the bone marrow. The thymus is this organ that when a person or a horse, when any animal is born, it sits behind the heart, and it is bigger, and as the person, so very, very ready to make T cells. And as the person, as the animal ages, the thymus becomes much, much smaller, and the ability to also form T cells is decreased substantially. The bone marrow is going to form and mature B cells, which are antibodies, and the bone marrow also is what makes other white blood cells. And then we're going to have lymphoid organs throughout the body, such as like lymph nodes, and they are going to, the spleen also serves as a lymphoid organ, and this is going to be areas where these B and T cells are going to live and are going to be released when the time comes. Okay, this obviously is a picture of a guy as opposed to a horse, but the lymphatics is the lymphatic vessels. They serve, it's like a system of highways that is right beside the blood vessels, but not the blood vessels, and they have multiple functions, but one of them is to remove the excess tissue fluid. So as the blood continues to flow a little bit, always is going to leak with or without inflammation. If anybody has traveled in an airplane for hours and hours, like 10, 15 hours, when you get to your destination, your legs may be a little bit more, so your feet, because of poor circulation at the time. But the lymphatics are going to help remove that excess fluid and dump it back into the blood circulation. But one of the most important things is that these lymphatics, they work as these systems of highway to fast track the movement of these white blood cells or these antibodies into the area that actually needs. Okay, so that's why here, transport immune cells to circulate, and then they also, these immune cells go to the lymphatics and then go straight to the lymph nodes to continue to form, to duplicate and form, multiply even more. So we have, like, the adaptive immune system has memory, so those are going to be stored. And when we see that particular pathogen again, microbe again, that memory gets reactivated, and now we have multiple of what we call daughter cells being formed from those memory cells that we had to start with. And that's why the second exposure of any disease forms antibodies super, super quickly. And I'm going to draw a graph here soon when we talk about vaccination to depict that. So the adaptive immunity is going to be, it's to adapt to infection, is learned by experience. So the more you get in contact with that particular microbe, the better your immune system against it is going to be. It is pathogen specific. Okay, so because you have great immunity against, say, influenza, doesn't mean that you have great immunity against herpes virus, because it's pathogen specific. Okay, and unlike the innate immune system, in that they use broad parts of the pathogens, the adaptive immune system is going to be very specific for each specific pathogen. Okay, so it's not broad. It's not like the immune system is going to be, the innate is going to be activated the same way if it is E. coli, salmonella, etc. This one is very specific. Enhanced by second exposure, has memory, is not very effective without the innate immune system, because it needs that to say. So the innate immune system is there as, like I said, sentinels, and they're just flagging, grabbing things, and then are going to be introducing, showing, say, hey guys, I found this invading microbe here. Somebody come and grab it from me, and start making antibodies against it. The adaptive immune system, hold on just a second. The adaptive immune system has two parts. One is the cell-mediated immunity, and they're made of the T cells, and the other one is antibodies, which is the humoral immunity. Do we have to know this? No, but it's important that everybody understands that there is, the bone marrow is important, and also the thymus is important, okay? The T cells, they are from the bone marrow, but they mature in the thymus, and they are going to produce the cytokines. We have different types of T cells, okay? But they are going to limit infection, but doesn't totally prevent the infection. So they kill these pathogens also, but they don't prevent infection, as opposed to, say, antibodies are actually going to prevent or give an infection that is more mild, okay? Allow an infection that is a little bit more mild. The B cells are going to, they're formed in the bone marrow, where they also mature, okay, as opposed to the T cells. They go to the lymphoid tissues, and they proliferate, and they make what we call daughter cells, which is like a lot of them, and they are what are known as antibodies. So antibodies, they are able to actually prevent infection, but they need to be in the right location, in the right concentration. So if you saw this particular microbe 20 years ago and never been exposed to it again, your antibody response to it may be a little bit more slow, because you don't have the right concentration. So you need to be able to be exposed to the same microbe, and that's why, especially in horses, we vaccinate them a lot of the times annually, sometimes even twice a year, to continue to, because the immune system is just like another system. If you don't use it, you lose it. So you need to keep it very active to be able to be on its prime strength when any kind of disease arrives and afflicts the horse. Okay, there's different types of antibodies. We're not going to go into it in details, but IgG is the most common circulating antibodies. IgM is the first type of antibody formed when we see infection. It's just the first one to try to limit the infection. IgG takes a few more days to be formed. IgA is formed in the mucosal membranes. So it's very important for diseases that start in mucosal membranes, such as any type of respiratory disease, for example, okay? So how do we activate the immune system? So we need to be pathogen specific, and this is why we vaccinate horses. Vaccination along with management measures is the primary method to effectively control infectious diseases. The reasons for vaccinating are to aid the prevention in the disease, to reduce the severity of the disease, and to minimize the spread of the disease. This is to prevent the disease. So when an animal is vaccinated against a disease and it sees that pathogen, it gets in contact, is exposed to that pathogen again, it is not going to get the disease. Now, it's not every single vaccine that works 100%, but some of them do. Some of them are going to just reduce the severity of the disease. For example, influenza, you may, hold on just a second, you may have a more mild form of influenza as opposed to just being prevented from getting the disease altogether. And then to minimize the spread of the disease is this thing that we call herd immunity. And herd immunity is very important, because say we have one animal here that doesn't mount up, because just like other systems, the immune system is just a system that is going to fail for some animals, as other animals, or some animals cannot be vaccinated. But say you have a ton of animals here that are immune to the disease because they are fully vaccinated, because these guys are all immune to the disease, it's going to be hard for this animal to actually get the disease, because one animal transmits to the other. But if all of them are immune, they're not going to be transmitted, they're not going to be getting the disease. So that's the importance of herd immunity. So any kind of vaccinations that we have, I guess rabies is one that doesn't work like that, but I don't know of another vaccine that is the same way. But we have one, the primary vaccination is to establish the antigen specific memory. So just to establish that. And then the second one, and sometimes the third, some vaccines need 3 initial doses, is to prevent antibody decay and to wake up the adaptive immune system. So just to maintain. So I'm going to make a little graph here. The initial vaccine, so you vaccinate here, and this is the concentration of antibodies in the blood. This is time. And when you first do the first dose, it is going to be more or less like this. This is in weeks. So it's going to take about 2 weeks for the antibodies to be formed initially, but the protective amount of antibodies is here. The first dose of any vaccine is not going to most likely reach levels that are protective in the animal. And then that's why after 30 days or after 45 days, generally it's 30 days, you give the vaccine again. And then the response is much higher, and the decay takes much longer, may take even up to a year, sometimes 6 months, but the response, the formation of antibodies, as you see, is much higher, and the decay takes much longer. So you have circulating antibodies hanging out in the blood, in the body, for much longer. Okay, and that's why here, again, when it starts to decay again, you rebooster that animal again to wake up the immunity. And if this animal gets in contact with the disease anytime here, the antibodies will fight off that disease. Factors affecting the immune response. Anything is going to affect. So age, as animals age, their immune response is not as great anymore. People, etc. Genetics, antigen exposure. So if you are never exposed to any antigen, your immune system is not as strong, and definitely doesn't have any memory if you've never been exposed to something. And that's the problem with when diseases first arrive, when diseases are first happening, nobody has antibodies against it because nobody has been exposed to that antigen, and it becomes a problem because we don't have what we call herd immunity. Lifestyle, a person, for example, or an animal that's stressed all the time, and I have here stress even as a separate one. A person or an animal that's stressed all the time, goes to bed late, wakes up late, drinks all the time, doesn't eat good food, only eats Pop-Tarts, only eats donuts. That is not a good lifestyle. You're not feeding your body. You're not treating your body well enough to be able to have a healthy immune response, okay? Stress, everybody, when it's finals week, because of the amount of stress you're in, so your body starts to actually, a lot of people come down with especially respiratory diseases when it gets to finals week, or any type of stress that happens in their family is going to happen. So people that have herpes virus, so you're going to see cold sores when they are stressed, etc. Exercise. So here, lifestyles. For example, in horses, a horse that is under stress all the time is never outside, is always in a stall, is always being ridden very severely. It's never, given time to rest. That is stressful for an animal, and that can decrease the immune response. Nutrition, obviously, what I just said, if you just eat donuts and Pop-Tarts. Gut microflora is important. It's important that we have a healthy gut microflora to be able to combat, and there is research upon research showing that it is very important to have a healthy gut microflora. And then hormones are also very important. When you have a lot of stress, you are releasing the hormones like called cortisol, and we're going to talk about this when we talk about steroids. And that is a hormone, and that's an endocrinological problem, and that is going to limit the immune response also. The immune system is a very delicate but needs to be very balanced system. So this is a balanced immune system for optimal effectiveness. Here we have internal threats, external threats. So let's see external allergic reactions. If we have a high overreaction of the immune system, it's people that have allergies about absolutely everything. It's an immune system that is exaggerating in its response to an external threat, and an immune system that is underreactive, that is not reacting well. It's a person that's going to have infections all the time. For external threats, for internal threats, an immune system that is overreactive is going to lead to autoimmune problems such as lupus, such as mast cell disorders, such as rheumatoid arthritis, multiple sclerosis, etc. So that's when the body is overreactive against its own self and causing autoimmune diseases. And then if we have an immune system that is underreactive and the threat is internal, sometimes there are some cancers, if you guys don't know, but there is cancerous cells being formed in our body pretty much every day, but the immune system takes care of it and gets rid of it. If you have an immune, because of stress, because of lifestyle, an immune system that is underreacting to things, then it can slip that one cancerous cell and allow it to continue to grow, and it can become a problem. Okay, so this is what I had to talk about the immune system. And this is the part 2. So if you have any questions, don't hesitate to contact me.